What I'm about to show you here is how to do some very basic data analysis. And I know that even as you look at this screen, you might be going, I hate data. This just looks busy and messy and complex and complicated, but I want to show you that it's not. And so I'm going to make this very simple, and we're only going to look at one particular type of data analysis. Now, first of all, let me just explain what's on the screen here. I've set up a nice user-friendly template which you can use to either analyse your own data or to use this sample data that I've provided. Now, this is a random sample of 15 participants in a program that I've conducted. And what you can see here is, first of all, under the red column, they're pre-test data, so they're information at the beginning, their survey results at the beginning of the program, and then their post-test in green here, which is their data, same measures at the end of the program. You can see that listed along in the blue are the various domains of wellbeing. So there's their BMI, their perceived health, health behaviours, mental health, vitality, depression, anxiety, and so on and so forth. And then these repeat because they've been measured once again at the end of the intervention. Now, you might be asking, well, where did all of this data come from? Well, let me show you. I've actually got a sample here, and you can see this should look very similar to your Livermore score that you conducted as well, if you did that as part of your program. So what you can see is I'm not worried so much about this Livermore score because that's an algorithm that I created that's not validated, but what it was derived from are all of these measures listed down here, all of these items, these various domains of wellbeing that are derived from validated instruments. And so this is actually the data from subject 1, you can see, and they're appearing in line 1 there. And so we have 23 for their BMI, and then we have 83 for their perceived health, 70 for their health behaviours, and so on and so forth. So I've actually transcribed this data into the pre-test results, and then this row of data into the post-test results. If I move that, you can actually see all that appearing along the top there. Now, what I want to say is that if you have a lot of people, that's obviously going to take you some time to do. There is a slightly faster way to do it, and I'll show you very briefly. But if already you're going, well, that's good enough, I can just do that, that's fine. You will notice though, so just tune out if you want to pause for a moment, you're happy just to do the manual entry method. In your Livermore score, there's at the last tab down the bottom there's an office use only. And if you scroll across, you'll find in blue, there we have it, all of those measures. If you were to copy them, and I may as well do it, if I were to copy them, and then I was to go over here and I'll repaste them, I'm going to paste it. I need to paste special because I just want the values, and OK, and I am done. So you can see that this is where all the measures have come from. So I have 15 participants, and here is their pre and their post data. So how do we analyse this? What are we interested in? Well, there are a number of things. First thing we'd like to know is there a change? In fact, that's our primary interest. Is there a change from pre to post? How would we test for that? How would we analyse that? Well, one of the first things we can do is to find out, well, what was the average, say, BMI at the beginning of the program, and what was the average BMI at the end? Let's have a look at that. Another word for average is obviously mean. And so Excel's very handy for doing this. All we have to type in, and if at any point you need to pause this video or replay certain sections, feel free to do that as you watch what I've done. So if I type in equals average, and then I open my bracket, it just says to me, or what would you like to average? And so I'm going to highlight all of BMI 1. I'm going to close the brackets and hit return, and it does it for me. So no calculator required. What a wonderful thing. And so here we have the average for their pre-test BMI appearing in that column. Now, you don't have to do every single one all the way along because Excel makes it easy for us, and this is how it happens. If you click on that first number and then drag your cursor all the way to the end and go edit, fill to the right, wowum! It's an amazing thing. It's a beautiful thing. Look at that. It does it for you. And so it just knows that, oh, I'll follow the pattern. So that was the average for that column. This here, you can see the formula up the top. It knows to average the same from D4 to D18, D4 to 18 in column D, and this one will be E, you can see, and F, and so on and so forth. So we have all the averages, which is a fantastic thing. Now, I've made this very easy for you, and I've actually created a little table, and this is the kind of table you would see in a publication. And what this table is doing is auto-populating as we're doing these calculations. So now you can see that in our pre-test, here is all the various domains of wellbeing down the column. And here are the mean results for all of those. There are the pre-tests, and here are the post-tests. And I've actually gone one step further. I've actually now looked at what's the change in this. So what's the difference between the post and the pre? And the way that you calculate that, if I click on, you can see the equation. It's just the post minus the pre. And so you can see for BMI, there was actually no change. Okay? Well, our program wasn't really targeting weight loss anyway, so maybe that's okay. But what our program was targeting were some other things, and let's see, we can actually see there have been some changes here. For example, perceived health, the way that they perceive their health has increased by about 4 points out of 100, possible 100 points over the course of the intervention. Now, what does that mean? Is that significant? Is that noteworthy? Well, we'll ask that question in just a moment. Perceived health behaviours have gone up slightly, it looks like, but look at this. We've got some big changes here. Their mental health, which was an emphasis of this program, has increased by 17 points out of 100, on average, that is. Now, that's possibly noteworthy. We still don't know, is that a significant thing? Is that just happened by chance? That we've just so happens, of these 15 people, was that just a random event? How much credibility can we place on that? So we're going to ask that question in just a moment. You can see though, look at this, some of the things have actually gone the opposite way. And all that means we've actually had a decrease in some of these items with the negative signs attached to them. Decrease in things like, well, the good news, things like depression, things like anxiety, stress has gone markedly down. Now, I want to tell you, this is the first time I'm analysing this data, so this gets me pretty excited. And I'm hoping you see now the beauty, the fun part of data analysis, when you start to see, hey, some of these changes look really quite intriguing. The question arises, though, how significant is that? How noteworthy is that? And so I want to introduce you to a test that can help us decide that. But before we do that, I want you we're going to do one other calculation. Not only are we going to calculate the mean for each of these various domains of wellbeing, we're also going to calculate another thing called the standard deviation. Now, the standard deviation is just a measure, and I don't want to get too complex, but it's just a measure of how much spread, how spread the data is. And you'll see why that's important to know in just a little while. But this is how you calculate it. Excel makes it, once again, very easy. Click on the cell that we want to populate, and we write equals. And we go, start writing standard deviation. You can see already it's going, I think I know what you want to do. And so it's saying, is this the thing? And I'm, oh, that's exactly it. So I'm just going to keep on typing that anyway. Standard dev there. I'll open the bracket, and it says, what would you like me to take the standard deviation of? I'll highlight the data set once again. Close the bracket, hit return, and it's now punched out the standard deviation for that array of data. Just like I did before, so that I don't have to do that for every single one of those columns, I'm just going to highlight the lot. I'll go edit, and I'll say fill right, please, Mr. Excel man or woman, and it's done it and auto-populated all of those for me. Now, I've actually set this little table so it's capturing all that data and auto-populating as well. So now you can see you're getting very close to having a completed table. You have the pre-data and the post-data, both the mean and the standard deviation. So let's come to a question that I posed just a moment ago. How do we know if, say, this is a significant result, a 4-point increase out of 100? Is that noteworthy? Is that significant? What about that? Certainly seems to be. Well, how can we know? Well, we have a convention in the sciences, and it refers to this thing called level of significance, or it's abbreviated, as you would have come across these already, as the p-value. Now, I want to humbly apologise to the biostatisticians amongst you, and I know there are some there. This is very, very basic analysis, so I'm just introducing some really basic concepts as we start to learn about some of these statistical methods. The thing we're going to be doing is a t-test, and what this t-test is going to do is test whether there is a significant change from pre to post. And it's going to produce a number for us called this p-value, this level of significance. That number will be between 0 and 1. Now, the closer it is to 1, it seems a bit odd and counterintuitive, but the closer it is to 1, the less significant it is. The closer it is to 0, the more significant it is. And, I sort of apologise for how simply I'm presenting this, but this would be one way of thinking about it. If we got a p-value of, say, 0.90, what that's sort of saying is that there's 90% chance that they're not different. That these two samples that you just gave me, that they're not different. There's 90% chance. So a p-value of 0.90 indicates there's 90% chance that they are not different. So we would conclude under those circumstances that, they're essentially the same. There is no significant difference. In the sciences, though, the convention is that if that p-value gets below 0.05, in other words, that's like saying there's 5% or less chance that they are the same, then we would conclude that they are significantly different. So let's see how we go about calculating that p-value. In much the same way we did before, we click on the cell and then we type in equals, and we want a t-test we're going to do. You see, it's already onto it. It is a NOAA. So t-test, and then I'm going to open the bracket, and it's going to ask me for a couple of things. First of all, it's going to say, well, what's the first array of data? And let's do BMI. So I'm going to highlight that. That's the first array of data. Then it says put a comma in there. Then it says, now I want to know what is the second array of data that you want to compare this against. And that is the BMI at the post-intervention mark. Then I hit a comma. And then it says, how many tails do you have to this? Now, I don't want to even go there and tell you what this all means, but let me just tell you, put number 2 in there, because 2 is a lovely number. Then a comma, and then the last thing it asks you is what type of t-test is this? And there are various different types, and the one that we're doing, though, is what's called a paired t-test. And the reason this is paired is because these people sampled here are the same as these people sampled here. Not only are they the same, we've actually been able to tell the computer that this one is the same person as that one, so it pairs the data. It changes the analysis slightly and makes it a bit more sophisticated. But anyway, the takeaway message is that all you need to do when it asks for type is press, if it's a paired t-test, is type number 1. Close the brackets, hit return, and it has just now produced a p-value for us, a level of significance. And it's saying that that p-value is 0.825. Or in other words, what it's saying is that there's an 83% chance that they are the same. We would conclude from that they're essentially not different. There is no significant difference here. The table I've produced, you see, auto-populates that. And so what we could see is this is sort of the kind of outcome we'd expect. There was the mean BMI was 21. The pre-one, that was 21. The post was 21. That's really no change. We saw really no change, no difference. So it's not likely that we would have seen a significant difference between those last two. But once again, BMI wasn't the emphasis of this program. It'd be intriguing to know what happens in these things here. So, let's find out. You know what? Excel is so smart that we can actually do, instead of having to do each one of these individually, we can do the same as what we did before. I'm going to click on that. I'm going to scroll across just to halfway this time, because this data, it's calling on this set data anyway. And I'm going to go Edit, fill to the rights, and presto, it has calculated all of our p-values for us. The table I've created has auto-populated them down here, and so let's see what we have, friends. Here is the exciting parts of data analysis. This we saw is not significant. Look at this one. You know what? At the 0.05 level, this is significant. So we would actually conclude here that in terms of their perceived health, what's actually happened is we've seen it go up from 72 to 76. That was a 4-point increase. And that is significant at the 0.05 level. Let's look at the next one. Health behaviours, 0.066. You know what? That hasn't quite made it. Now, why 0.05, I hear you ask? Great question. It's completely arbitrary. So that's in the sciences, that's what we tend to use, that 0.05 level of significance. Sometimes we use 0.01 level of significance, and we talk about that as being highly significant, as I mentioned just a moment ago. So what we could say is this one was borderline significant, but didn't quite get there at the 0.05 level. Now, if you're astute, you're probably wondering, wait a sec, there was a 5-point increase in this one, and yet it wasn't significant. And there was a 4-point increase in this one, and that was significant. Why is that? Well, this is where that standard deviation comes in. And if you don't want to know about this, just tune out for just a moment. But for those who do, what happens is, have you noticed that, see in this row here, the standard deviation and the measure of spread of this data set in the pre, and then once again in the post, was tighter. It was smaller than the spread in the health behaviours data. And what that means is when you have the data more spread out, it's harder to achieve significance. The tighter it is, the more significant things become. So that explains that. Let's have a look down here. Look at this, mental health. Now this is pretty exciting to me because what we've actually seen is a 17-point increase there out of 100. And that is highly significant. So the change in mental health, highly significant. In fact, that's even significant at what we would say a 0.01 level. This is actually saying that there's one chance in 1,000 that this is just a random fluke, that data. We would convincingly say there is something very real in that. It certainly seems that these people they improve their mental health throughout the program. Vitality, look at that. Essentially not. And we'd probably expect that. You see that there's essentially no change in their vitality, and the p-value reflects that. We have depression. Depression, there is a significant reduction at the 0.05 level, and even almost at the 0.01 level. And it is a reduction, which is a good thing. Anxiety has significantly reduced, even at the 0.01 level, which is very exciting. And this one here, look at that. That is super highly significant. And you can see it's represented by that number. So their stress levels have really gone down as a result, well, through the course of the program. And, we would hope that it's due to the fact that they had actually, engaged in this program and done, well, essentially learnt from the zebra and doing what the zebra has taught us or can teach us. I find that particular result very, very interesting, given that it's actually coming to the end of the semester. And so you would think that these students, which was the data set we drew this off, would actually have increased their level of their stress. But, we've actually seen the reverse there. Social support, there was a slight decrease, but only 1 point, which you wouldn't make much out of, and certainly the significant levels indicates that there's nothing in there. Their flourishing didn't really change. Their personal beliefs, well, there was a 7-point increase, but because the data was so spread, you see these high standard deviations, essentially there was no significant difference. We've just reached significance with the spirituality and their spiritual satisfaction. So we've sort of seen a small incline in that. And then almost, very close, significant increase in their overall life satisfaction. I hope this gives you some insights. And the t-test is only just one test that we can use, but it's probably the most relevant for this particular study and this particular question that we're asking, and that is there a change from the beginning to the end in these participants' domains of wellbeing? As I said, there are many other very sophisticated analyses that we could do, but this is a great place to start. And so you are free to actually, you could write up based on this data set, or perhaps you could even insert your own data here, and it should auto-populate itself and create your own analyses. So I hope this is a brief introduction. I hope that makes sense and that's helpful for you in understanding how to do some basic data analysis, specifically how to do t-tests.